we talked about compound interest and how it, you know, basically you get your interest calculated every so often, whether that's once a month or once a quarter, every 3 months. Um, I want to talk about this real quick because if you look here, it says we're gonna write some stuff in up here, but I just want to give this first example as to why we're going to be doing what we're doing today. So it says that State Bank pays 6% interest compounded quarterly. So that would be once every 3 months, just like we did 4 times a year, just like we did on a lot of those examples yesterday. On regular savings accounts, Marta Carmona deposited $3,000 and it was in there for 2 years. She made no other deposits or withdrawals. How much interest did Marta earn during the 2 years? Now, here's the problem with that. If we were to use what we did yesterday, this problem would take a really long time. Even the ones that we did yesterday, where it was quarterly for a year, we had to do 4 separate calculations for interest. And that was for 1 year on quarterly. Think about this here. This is for 2 years for quarterly. So we'd have to do 4 quarters for the first year, 4 quarters for the second year. We were looking at 8 calculations total, which would be a little bit annoying, I think, to have to do one problem and do those calculations 8 times in order to make this work correctly. So wouldn't it be nice if there was a formula that would allow us to calculate compound interest in just a single formula? Wouldn't that be nice? And thankfully, there is that formula, and that's what we're going to be working on today. Now, there's a table method that the textbook uses. We're not going to be doing that. So if anything refers to using a table, don't do it. We're not using tables. So we're going to be dealing with a compound interest formula today. So the simple interest formula that we've been using was, the interest is equal to the principal multiplied by the rate multiplied by the amount of time. Today, this is called the compounding interest formula. And compounding interest, tables are overrated. Yeah, well, tables are a good thing because they allow you to see patterns, but we saw that pattern yesterday, so we may as well just go straight to the formula today. Compounding interest is much more common than simple interest. So if you're ever, trying to figure out how interest is calculated, chances are it's going to be compounded interest. And so this formula is a lot more likely to be used than the simple interest formula. And so the formula is right here. It says that the amount, so here it doesn't actually it doesn't calculate the interest for you. It calculates your final amount. So this is one of the big differences between the compounding interest formula and the simple interest formula. The simple interest formula gives you the amount of interest, which you then have to add to the principal value at the end to get the final amount. Compounding interest formula just goes straight to the final amount. And so the amount in the account is equal to the principal value, P, times, and then we have parentheses. We have 1 plus R. R is going to be a little bit different than R from simple interest. I just want to be up front with that. And then to the n power. So there's an exponent in this one. So this is our compounding interest formula here. And this R, I just want to make this clear again, this is not the same R as in the simple interest formula. It does have to do with the rate, but it's not quite the same. It's a different type of rate. We'll see in just a second. So over here, I'm going to break down what these variables are. So A is the new amount. P, principal, just like we've been dealing with. Or if you want, original amount. The principal or the original amount. Now R it does have to do with the rate, like I said, but it's the rate per period. So it's not just the total rate. So R, there's a little formula for this as well. R is equal to the actual rate, that's your decimal there, divided by the number of periods per year. So number of periods per year. Not the total number of periods, but the number of periods per year. So if it's quarterly, this would be divided by 4. That would be the number of periods per year. If it's a monthly, that would be divided by 12 because that's, you know, the number of months in a year. So that's the number of periods per year. And then N, that exponent, is the number of total periods. Number of total periods. All right. So this is the formula we're going to be using. I'm going to walk you over to the Desmos calculator here in a few minutes because that's basically the one that I'm going to be teaching from today. You can also do this on a regular calculator, but I figure since we're online, we may as well use that. So I'll get that ready over there. Okay. Here we go. Let's go ahead and put a quick example in up here. So let's say you open an account and you open your account with $3,620. So you have a principal value of $3,620. Now the account is compounded quarterly. So every 3 months. Compounded quarterly at 6.5%. So that's the basic rate right there. And we need to find the amount after 9 months. So find the amount after 9 months. Now, we did something really similar to this yesterday. We would have done this yesterday. We would have just done the calculation 3 times and just added the interest each time to the new principal value, just like we did in the notes. Now, we're going to be using the formula today, so it's going to look a little bit different. So let's go ahead and sort out our variables here. So we've got A, P, R, and N. A is the thing we're trying to figure out. So we don't have a value for A yet. We do have a value for P, though, the principal value, the original amount, $3,620. So P, $3,620. R, like I mentioned, R is not just the rate. R is equal to the rate divided by the number of periods per year. So the rate here is 6.5%, so that would be 0.065, divided by the number of periods per year. If it's compounded quarterly, that means it's compounded 4 times a year. So that's 0.065 divided by 4. Now, if it was compounded monthly, we would do this divided by 12. If it was compounded daily, it would be divided by 365. So it just depends on how frequently it's compounded over the course of the year. And then we need to know the value of N. And N is equal to the number of total periods. So 9 months. How many quarters is that? How many quarters of a year is 9 months? Somebody type that in for me. How many times will it be compounded over 9 months? Keeping in mind that quarterly is every 3 months. Yeah, 3, exactly. So n is going to be equal to 3. The total number of periods, the total amount of times that that interest will compound over 9 months is 3 times. It'll compound once after 3 months. It'll compound second time after 6 months. And it'll compound the third and final time after 9 months. So n equals 3. So we are going to be plugging these in here, those 3, because in this formula, there's only 3 numbers that we need to plug in for, p, r, and n. And we have the value of p, we have the value of r, we have the value of n. So we can plug those in now. And we can say that A, the amount in the account is equal to 3,620 times, that 1 is always there, 1 plus the value of r, which is 0.065 over 4, all to the third power. Now, we could go through this and we could use order of operations and kind of sort out the stuff on the inside here and then take it to the third power and then multiply it by 3,620, or we can just go to Desmos and deal with it there. So let's do that. I would much rather do that. So I'd like you all to go to the Desmos scientific calculator, please. Everybody head there. Because as with anything technology-wise, you need to know how to use this stuff in order for the answer to come out the way it needs to. So everybody head to the Desmos scientific calculator. I'm going to go ahead and share that screen as well. Here we go. And what we're going to do is just type in the problem exactly as we see it, which is a really convenient thing to be able to do. So it's equal to, the new amount is going to be equal to the principal value, that's that 3,620. Then we're going to multiply it. And we're going to open up a set of parentheses. We're multiplying it by 1 plus. And then the value of r is 0.065 over 4. So we need to set up a fraction here, actually. And in Desmos, the fraction button is just this a over b button. So once you have the 1 plus, type in or click the a over b button. And I'm recording this as well, so if you need to go back later to watch it again, it'll be in here. 0.065, and you can just click down here over 4. So that's our value of r. And then I'm going to hit the right arrow on my keyboard to scroll over because we need to close the parentheses, but we can't close the parentheses on the bottom of the fraction. We have to close it to the side of the fraction. So we scroll over once, close our parentheses. And then we need to get the power of 3, an exponent of 3. So these two buttons over here are both exponents. The a to the second power is just to the second power. A to the b power is to whatever power you want. So we're going to click on a to the b power, and then we're going to type in 3. So there we have it. We've got p times 1 plus r all to the third power, and all the numbers are typed in where they need to be, and we hit enter, and there's our answer. $3,799.36. So that's our answer right there. Basically just making the calculator do the work for us. So we get $3,799.36. Now, because this gives us the amount, it doesn't actually give us the amount of interest that was earned. So if we want to know how much interest was earned, we just take our new amount, that $37.99.36, and we subtract the principal value of $36.20. So interest earned is 179.36. So if something asks you to calculate the amount and find the interest, that's how you'd find the interest. You just take the new amount A, subtract the original amount P, the principal value. And that will give you what you need. So there it is. New amount, $37.99.36. Interest amount, $179.36. All right, let's try the next one. It's down here. Example 1 is what it says. State Bank, this is the one that I just looked at a few minutes ago and kind of was like, hey, we'd have to calculate this interest 8 times. So 6% interest compounded quarterly. So that right there gives us R, 6% interest compounded quarterly. That would be R equals 0.06 over 4, because it's the rate right here divided by the number of periods per year. Rate is 6%, 4 periods per year because it's quarterly. Marta Carmona deposited $3,000. Okay. So P equals 3,000. And then she wants to know how much money she's going to have in the account after 2 years. So if something compounds 4 times a year quarterly, but it's compounding for 2 full years, how many total periods is it being compounded for? Somebody tell me that. 4 times a year for 2 years. How many times will it be compounded in that amount of time? So if something is compounding 4 times a year for 2 years, how many times total will it be compounded over those 2 years? Four times in the first year, another 4 times in the second year, for a total of how many times? It's 8. 8 times. So something compounds 4 times in 1 year, 4 times the second year, that's a total of 8. So the number n, our exponent in the formula, number of total periods that it gets compounded over, 8. All right, so then we're going to use our formula, this one up here, the A equals P times 1 plus R in parentheses to the n power. So we're going to get the new amount, and the amount is going to be equal to the original principal value, 3,000, multiplied by 1 plus the value of R is right here, 0.06 over 4 to the 8th power. Okay. Switch it back over to the Desmos calculator now. We're going to type all that in, get our answer. So 3,000, that's our value of P, times, open your set of parentheses, 1 plus, now we need to get our fraction going, and we had 0.06 or 0.06, either way, over 4. Scroll to the right, close your parentheses. And the 8th power, that's a to the b, and then type in 8. And there it is. So after 2 years, the account will have $3,379.48. That's how much money will be in the account. Now, if you want to calculate the interest, again, you just take the new amount, 3379.48 minus the original. So that's $379.48 in interest earned over those 2 years. So the interest would equal $379.48. All right, so there's that right there. All right, here we go. These next ones, number 1 and 2. Here we go. So number 1, Ed Cure invested $2,000. All right, P equals 2,000. 5.5% interest compounded quarterly. So R, 5.5% is 0.055, 4 times a year, so over 4 for 2 years. So again, N will equal 8. 4 times a year for 2 years is N equals 8. So we're going to throw this into the formula. We're going to say A is equal to P, 2,000, times, parentheses, 1 plus the rate, 0.055, compounded quarterly for 2 years to the 8th power. So what I would like you to do is run that through a calculator and give me an answer. So I'm going to give you 1 minute to get that typed into a calculator, and then somebody type in what you get for your answer. And it doesn't have to be to the entire class. It can just go straight to me. That's fine. But work that out. Let me know what you get for A, just for A. Anybody have an answer? So far, I'm interpreting this as, no, Mr. Myers, I don't have an answer. Hope people are out there. Are you there? All right. All right, well, let's go ahead and I'm going to go ahead and show you the answer, and then we'll see what we need to do with the calculator. What's going on? We are calculating, hopefully, doing problem number 1 that I wrote down at the bottom of the paper there. The A equals, all I need you to do is type that into a calculator. The A equals 2,000 times, and then in parentheses, 1 plus 0.055 over 4 to the 8th power, and give me an answer to that. That's all I'm looking for right now. Hopefully nothing too crazy. Okay, there it is. So when you plug it in, you should end up with $2,230.88. So again, I'll go ahead and share. Oops, I never had, oh, that's why. I'd never transferred it back over. Sorry about that. So let's try with the second one then. So this is what we had here. I apologize for that. I was not on my document camera. I forgot to switch it back over. So let's go ahead and we'll do the second one. So we did I did number 1 because I forgot to switch it back to my document camera. Sorry about that. So with number 2, let's do that one real quick. So Louisa Foster invested $4,500. So the principal, $4,500. Hopefully we can see this now. Down here at the bottom of the page, $4,500, 3% interest compounded semi-annually. Semi-annually just means twice a year. So 2 times per year for semi-annually. So for the value of R, it's going to be the actual rate of 3%, 0.03, divided by the number of periods per year, 2. And then N will be the number of total periods. So if it's compounded twice a year for 2 years, it's going to compound 4 total times over those 2 years. And we're going to plug that into our formula. So hopefully, Spencer, this time you can see SS hit. I'm hoping that can be seen now. 4,500 principal times parentheses 1 plus the value of R, 0.03 divided by 2, all to the 4th power. And so let's try it this time. Hopefully you can see that now. So go to your, go to the Desmos calculator, type this in now, and then once you get an answer for it, let me know what you end up with. That's what we're doing. All right. So does anybody have an answer? Because I think you can. I think we can see the Desmos scientific calculator now, right? So I'll head back here again. Back to the share. Here we go. So we should be looking at 4,776.14 for that one. And I feel like my computer might be automatically switching the screen share. So if it's doing that, that'd be a little annoying. Cool. Okay, so 4,776.14 for that one there. Example 2. Sorry about the technology weirdness today. I don't know. I'm not sure. Hopefully it'll work out. Elliot Frazier deposited $10,000 into a savings account, paying 6% annual interest compounded monthly. Now, present value is the same thing as principal value, principal amount, or original amount. There's a lot of different terms that we use for the same things when it comes to finance. So Elliot Frazier deposited $10,000 into a savings account. So principal, present value, original amount, whatever you want to call it, 10,000. So P is 10,000. Pays 6% annual interest compounded monthly. So R is equal to the 6%, 0.06, divided by the number of times it compounds per year, which is 12. I'm just going to double check, make sure I'm actually on my, yep, hopefully we can see that. Good. All right. So R is equal to 0.06 over 12. What amount, future value, or just new amount? So present value, future value. So there's different ways, like I said, different ways of saying the same thing. How much will he have in his account after 5 years? So N is going to equal 12 times a year. It gets compounded, multiplied by 5 years. So N is 60. So that's our exponent. So we're going to have an exponent of 60 on this one. So that's a very large exponent value, but it doesn't change in any way how we're going to do this problem. Now, I want you to pay close attention as well to the actual question being asked here. It says, what will he have in his account after 5 years? So that's one part of it. And how much compound interest will he have earned? So we need to do two things here. We need to figure out what A is, and we need to figure out what the actual interest I is. So the first thing we're going to do is figure out the amount. So we're going to use our compound interest formula. So we're going to say that A is equal to the principal amount, 10,000, multiplied by 1 plus the value of R, that was 0.06 over 12, to the n power. And we said n this time was 60. So here is what I would like you to do. Try this again. If you have your own calculator and you want to try it on that, that's fine. I've been going with Desmos today, so try it on Desmos if you can. Get that calculated and type it into the chat once you think you have it. Any guesses as to how much is in the account after 5 years? Value of A? If not, I'm happy to switch it over to the calculator. So go ahead and do that here. All right, here we go. Principal value, 10,000, multiplied by, parentheses, 1 plus 6% divided by 12 months, 60 total compounding periods. So there it is. So you should have $13,488.50 in the account after 5 years. Now, if we want to figure out the interest amount, just subtract the new amount minus the original, and there we have $3,488.50 for the interest earned over those 5 years. So switch it on back to the document camera. Then we've got a couple quick problems to do after that. Then we'll call it a day. So here we go. So those are the two answers right here. All right. So by the way, tomorrow, I'm trying to think what we've got in terms of the amount of lessons left in this chapter. I think it's, yeah, I think it's just one more. We might take a day tomorrow though, so we'll see. Take a day for questions, I mean. So number 3, how much compound interest will $50,000 have earned in 10 years at 6.4% annual interest compounded quarterly? So value of P. So number 3, value of P is equal to $50,000. Somebody tell me, what does R equal on this one? We always go with the rate divided by number of compounding periods per year. So what is our R value on this one? Somebody type that in for me. I want to get a little bit more participation if we can. Which hopefully means people are listening. So it's the rate divided by the number of periods per year. So what are we going to have for R? I feel like I need to double check. Is my screen share working right now? Can we see the paper? Excellent. Okay. So R equals the rate 0.064, 6.4% divided by compounded quarterly 4. All right, now we're talking about a total of 10 years here. So the N, the total number of compounding, total number of periods anyway, is going to be 4 times per year. So 4 multiplied by 10 years. So 4 times a year for 10 years means that N, our exponent value, is going to be equal to 40. So we're trying to figure out, first of all, how much compound interest as well. So this one, how much compound interest, means we're only solving for I on this one. But in order to get I, we have to get the amount first. We have to get A first. So A, 50,000 multiplied by 1 plus the value of r, 0.064 over 4 to the 40th power. So that's the equation that we'll be typing into Desmos over there. So I'm going to switch on over, take a look at it, get our answer here. So 50 grand multiplied by 1 plus 0.064 over 4. And that is all to the 40th power. So we're looking at quite a bit of growth here. We end up with an amount in the account of $94,344.88. So that means that there was a lot of interest earned. How much exactly is what we're trying to figure out here. So we have to take our $94,344.88 and then subtract the original amount of $50,000. So in 10 years, the amount in the account has nearly doubled, which is really actually quite good, especially since there wasn't any additional money added during those 10 years. That's kind of crazy. So $44,344.88 of interest was earned over those 10 years. So almost doubling the amount in 10 years. It's pretty good. All right, let's go ahead and take a look at the last one. We're starting to get a little bit short on time here. So number 4. This one's going to look a little bit different, by the way. So this says that Margie Spencer wants to have, this is where it gets different. Margie Spencer wants to have $100,000 in her savings account in 20 years. So that means 20 years from now, she wants to have $100,000. That means that A is $100,000. So A equals 100,000. So that's the goal. And this is actually a really good way to do goal setting for like financial stuff. How much money do you want to have in however many years? You can basically work backwards to figure out, all right, how much do I need to invest? So she wants to have $100,000 in 20 years. If her account pays 6.6% annual interest compounded semi-annually. So that's 2 times a year again. So R is 0.066 compounded semi-annually 2 times a year. So 0.066 divided by 2. And it says, how much does she need to deposit into her account now? That's the value of P, by the way. That's the principal value. How much does she need to deposit now in order to meet her goal? So we don't know what the value of P is. We'll figure that out, but we need to know what N is. And so she's going to be saving for 20 years, and it compounds 2 times a year. So 2 times a year times 20 years, N value of 40, just like the last problem, actually. So we get an N value of 40. And we're solving for P. So solve for P. Okay. So this one's going to look a little bit different, obviously, because now we have the value of A, and we want to figure out the value of P. So I'm going to write it like I normally would, but instead of A equals, I'm actually have a number for A. So I'm going to write 100,000 equals, and instead of a principal value, I don't have that. I need to figure out what P is. So P times, everything else will look the same from here, 1 plus 0.066 over 2 to the 40th power. Now, I can't just type that in and get an answer because I've got a variable. Now, one of the things about having a nice calculator or using the Desmos calculator is that it can do pretty complex things, meaning we don't have to figure out what this number is right here in order to divide, because that's what we have to do, right? In order to get P by itself, P is being multiplied by this. And whatever this is, it is one number. It's a single number if we do the calculation, but we don't need to do the calculation yet. We just need to divide by this number. So if we are to divide, let's take a look here, divide by the 1 plus 0.066 over 2 to the 40th power, those will cancel out over here. Because really all that is one number. It's a decimal value. We don't know what it is. We're not even going to find out what it is because we're just going to divide it on both sides. And when we divide on both sides by whatever that is, they cancel out on the right-hand side, leaving us with the value of P. So as long as we can type this correctly into the Desmos calculator, the 100,000 divided by all that, as long as we can type that in correctly, we'll be able to figure out what the value of P is, the principal amount, the amount of money that she needs to put in the account now in order to have $100,000 in her account in 20 years. So let's find out how much money she needs to invest. All right, I'm gonna do a new share. Hopefully we can see the calculator now, this online calculator here. All right, here we go. I'm gonna do a fraction and I'm gonna have 100,000 on top. And then underneath, I'm gonna do that parentheses, 1 plus, and then another fraction, 0.066 over 2, close that parenthesis, and then to the 40th, there it is, to the 40th power. And that's exactly what it looked like on our paper. So as long as we can write it on the computer just like it looked on the paper, that'll do the math for us, and there it is. So if she wants to end up with $100,000 in her account in 20 years, that means that right now she needs to invest $27,288.97. That's how much money she needs to put into her account like today in order to get that to work. All right, we are basically out of time. Now, your assignment for the day, let me just go ahead and open this up real quick for you. Your assignment is gonna look really similar to what we just did, obviously, because it usually does. These first, what is that? 6 problems, 5 through 10. Have 4 parts to them. I put the 4 parts over on the side here, so you can just type those values in over here and not have to worry about filling them in on the chart. It's essentially what we just went over. So it gives it in a little bit of a different way, but it's the same math that we did. 11, pretty similar. 12 is going to be a little bit challenging, but I want you to give it a try. 13 is a comparison, so you can just do a couple of quick calculations and figure out which one is better. 14, which we have in 30 years. So this one doesn't look like algebra to me. 14, that one looks pretty straightforward. This one here is 15 is just like the one we just did. 16, challenge problem. That one will be, yeah, that one will be pretty challenging. Number 20, 16, so a few of them were cut out. 20 is a kind of a recap, and so is 21, and I forgot to put a text box with that one, so I apologize, but try to type in for that one if you can. And I think we'll probably take a day tomorrow to go over questions on the last 2 days worth of assignments. So we're gonna go ahead and end it there. If you need to drop by for, yeah, you know what, since I don't know really when I'll be available for academic support tomorrow, just bring your questions for 5.5 and 5.6 tomorrow. And I'll take your questions on those two assignments, and we'll work through this stuff tomorrow with the questions that you have for it. So I will see you then. Have a great day. Bye.